From the last video, we know that this is the rectangular form of a complex number. We also know that this a is graphed as the x value and this b is graphed as the y value. That a comma b is the same thing as x comma y when we're graphing in the complex plane. Knowing this, it should make sense from our 6.1 lesson that we can then change a to be r cosine theta, because a is the same thing as our x value, and in 6.1 we learned that the equation for x is r cosine theta. If you don't remember that, you can go back and rewatch the 6.1 videos. We also learned that y is the same thing as r sine theta. So we can change b, which is basically our y value, to r sine theta. And then notice the y just stays tacked on to the end of it. So we have a is our x value, which is r cosine theta, and b is our y value, which is r sine theta. Then we can do some things to shorthand it. So first thing we can do is notice that they have an r in common, so I take it out and I get cosine theta plus I sine theta. Then even further, they shorthand this to cis. Cosine, I, sine. See how that's just the shorthand version? So basically this is just the lazy way to write this. So this one right here is what we call the polar form of a complex number, r cosine theta plus r sine theta I. This is the shorthand of the polar form. So now that we understand that, let's look at some polar form numbers. Here we have a polar form of a complex number, 4 cis 2 pi thirds. Or if we write that out not in shorthand, we know this would be 4 cosine of 2 pi thirds plus I times 4 sine of 2 pi thirds. This is your shorthand. This is your actual polar form. Now, all we have to do is simplify this using the unit circle, because I can do cosine of 2 pi thirds and sine of 2 pi thirds. Hopefully you're getting to the point where you can start to do these in your head. If you need to, pause the video and take a moment to draw out 2 pi thirds on your unit circle, draw your x and y values, and get those there. But we should be able to pretty quickly know that cosine of 2 pi thirds is -1/2. And sine of 2 pi thirds is √3/2, all off of our unit circle. Then I just multiply these together. I get -2 plus I to √3. This I really can't go anywhere. If you wanted to write it as like 2I √3 or 2 √3I, all of those are totally valid. I am not picky about where the I goes. So any of those work, but now we have changed it from the polar form written in shorthand out to the rectangular form. So now this is once again A plus BI. And we see our real part and our imaginary part. And we got that all from R and theta. So now that you've done that once, let's have you try one. So let's go over here to B. Here we have once again in shorthand R cis theta. I want you to pause the video, write this out all the way, and then use your unit circle to simplify it to end with the rectangular form A plus BI. Pause the video, try that out on your own, and then come back to check. Let's see how you did. Here's it written out all the way. Cosine of -3 pi fourths is -1/√2. Or you could also use -√2/2, same number. And sine of -3 pi fourths is also -1/√2. Or you could have used -√2/2, same number. And then if we multiply and simplify those together, I get this. If you had used this version of the number, you would have ended up with this. But these are totally the exact same thing. You're fine with either answer. And then I noticed there's my real part, and then here's my imaginary part. So now that you're starting to get the hang of this, let's do two more. We have C and D, which is 3 cis 0 radians, and D would be 1 cis pi halves radians. So same thing as before, I'm going to have you pause the video, write this out all the way, use the unit circle to simplify your answer, and then write your answer in rectangular form as A plus BI, or real plus imaginary part. So pause the video, try C and D on your own, and then come back to check and see how you did. Let's check your work. So here's writing it out all the way. Use my unit circle to simplify cosine of 0 to 1 and sine of 0 to 0. 3 times 0 is 0, so if I wrote it out as A plus BI, I would write it as 3 plus 0i, where my real part is 3 and my imaginary part is 0. You could also just simplify this to 3. We don't need the 0i there, because 0 times anything is just 0. So you could just simplify this as 3. D, write it out, 1 cosine of pi halves plus I, 1 sine of pi halves. Cosine of pi halves is 0. Sine of pi halves is 1, which is 0 plus I. Or you could just simplify that to I. You don't need to write the 0 in. But I wrote the 0 in so you could see 0 is the real part and 1 is the imaginary part. So now we know how to take a polar form, r cis theta, into a rectangular form, A plus BI. We have one more video to do today to finalize everything that we've learned, and then you'll be done with lesson 6.3.